Okay, we're gonna take some notes on piecewise functions. Just a little warning, this is a tricky topic. So if you're feeling kind of confused at first, hopefully it'll get better. We'll do more examples. But basically a piecewise function is a function where each piece has a limited domain. So there's a few things kind of to keep in mind with piecewise functions. So to graph a piecewise function, make a table for each piece is what I'm going to suggest. And if you already did the classwork that goes with today, 102 and 104, yeah, those were both piecewise functions. So when you make a table for each piece, you want to do a few things. Start or end at the ends of the domain. And then less than or greater than are open. And less than or equal to or greater than or equal to are closed. If 2 points overlap with one open and one closed, just put a point there. You don't do the open circle. And then if the pieces are separate, don't connect them. So what I mean by that, just kind of, I've seen this a lot. If you have a graph that say it has these kind of pieces, people tend to connect these circles, like with that orange line, and you don't want to do that. So that's a big no-no. You leave them separate so it can remain a function. So 9-103, I'm going to do on here. I'm actually going to do part B first. So the equation is f of x equals 2x minus 5 when x is less than or equal to 1, and x minus 3 squared plus 1 when x is greater than 1. So notice one has or equal to and the other one doesn't. They can't both have or equal to because to be a function, it can only be defined at one point. So I was saying make a table for both of these. So x and then 2x minus 5. So this is when x is less than or equal to 1. So -3, -2, -1, 0, and 1. You want to stop at 1. You can do as many numbers as you want that are less than that, but you have to stop at 1. And then I'm going to make another table here for the other piece of our function, x minus 3 squared plus 1. So this is when x is greater than 1. Even though it's not or equal to, you still put 1 in your table. So then numbers that are greater than 1. I like to kind of do this part ahead of time. So this point right here, whatever it is, this is going to be our closed circle. And this one will be open. again, because it doesn't have the or equal to. So you just take these numbers and plug it in. 2 times -3 minus 5, I get -11. 2 times -2 is -4 minus 5 is -9. 2 times -1 minus 5, we get -7. This is -5, and this is -3. So I'm going to go ahead and graph that part. Let's see. So 1, -3, 0, -5. Again, this is a closed circle. I didn't make my graph go very far down. That's okay. So this part would go like that, and it'll go on forever down to the left on numbers when x is less than 1. Here I plug 1 in. 1 minus 3 is -2. Square that, I get +4, plus 1 is 5. 2 minus 3, you can plug it in here, it doesn't matter. So 2 minus 3 is -1, squared is 1, plus 1, I get 2. 3 minus 3 is 0, squared, still 0, plus 1 is 1. 4 minus 3 is 1, squared is still 1, plus 1 is 2. And then if I plug in 5, I also get 5. So I go to the point 1, 5, and I have an open circle. 2, 2. 3, 1, 4, 2, 5, 5. And you should know by this equation that it's a parabola with the vertex of 3, 1, which we can see kind of from our graph. So this graph would go like that. And notice it's going to have that arrow off on that right side because it goes on forever. So we could keep going and plug in 6, 7, 8, 9, 10, and it'll look like that. But this one is closed and this one is open. Do not connect those points. That's what I was saying up here. Part A, it's similar but a little bit different. It has 3 pieces. So f of x equals 3 for -4 is less than or equal to x is less than or equal to 2. -2, I'm sorry. F of x is equal to -1. For -2 is less than x is less than or equal to +2. And f of x is equal to 5. For 2 is less than x is less than or equal to 5. So on this one, you have the option to make a table if you want. I don't think they're necessary because these are vertical lines, but horizontal lines, but I'm going to just to be consistent. So my first piece, it's equal to 3 for -4, -3, -2. And I stop there because that domain is just from -4 to -2. My second piece is -1, -2, -1, 0, 1, and 2. Again, the domain there is from -2 to 2. Even though it doesn't have or equal to, that just means it's going to have an open circle. You still want that point in your table. And the last one is 5 when x is between 2 or 5. So 2, 3, 4, 5. So if x is equal, this is just 5. These are constant functions. They're going to be horizontal line pieces like the step graph on 102. These aren't just going to be equal size steps. These are all -1, and these are all 3. Going back to those circles, if they're open or closed. So this guy and this guy are both closed. Again, because they both have the or equal to. Here for -1, when x is -2, this should be an open circle. And then it's or equal to here, so this should be closed. My third piece, 5. It's when x is between 2. So this piece is open because it doesn't have or equal to. But when x is 5, it should be closed because that piece has or equals to. So going to graph this, this is a point -4, 3. 1, 2, 3, 4, 1, 2, 3, closed circle. -3, 3, -2, 3, also a closed circle. So that's just that horizontal line. -2, -1, -2, -1 is my open circle. -1, -1, 0, -1, 1, -1, 2, -1 is a closed circle. So this is just like that. Notice this line is longer than this one because the domain was longer. Then the last one, 2, 5, I have an open circle. 3, 5, 4, 5, 5, 5, it ends there. And it goes like that. None of these have arrows on them, where part B up here had arrows. These don't have arrows because all of these have endpoints on both sides of the domain. Up here, it was x is less than or equal to 1, so that's any number less than 1, and it goes on forever. This has endpoints. Hopefully this helps. Let me know if you have other questions.